the new parameter that we are now differentiating, we are bringing up in sphere is theta. And theta is in sphere is in the third parameter. No, it's the second parameter. I've started confusing myself. This is the second dimension. There is something important about being the second or that one. Don't think I'm saying them for the sake of saying. We are saying that we arrange them in the following form: r theta phi. This is a point in sphere. If I was to write it a point in cylindrical, I would say a point with rho, then phi, then z. So you can see that one here is that parameter, and here is the second parameter. That is the point I'm trying to bring around. It is very important because when we start doing the unit multiplications, we're saying AR dot, okay, cross A theta cap. We are going to realize that this becomes the third parameter, which is A phi. So they follow that order. But if you confused and you thought that if this was the second one, it would give you wrong axioms or wrong cyclic permutation. So that is why I'm insisting about which comes where. So yeah, I think I'll send you some simple questions about how you can express a point in sphere, a point in cylinder, and a point in X, Y, and Z. I think that's good for an introduction. So the point idea I'm saying is that theta, which is the collocation, is measured from Z now. Is measured from Z going down towards R. Measured from Z towards R. And so if this radius is at the same point, at the same plane as the X and Y, then my theta would be equal to 90 degrees. Make sense? Hope yes. All right. So I have described those ideas about how each of them is formed. I think now is the time to mention the limits. We're saying R is ranging from 0 to infinity. Theta is ranging from 0 to pi. Trust me, I think it is important here to mention that the maximum value that you can have for theta is when you have gone to that point. When you can't start now going up. So if you are going up, you are going the reverse of theta. And therefore, it will be negative theta. So the maximum limit of theta is 180 degrees or pi. So this is the one I'm talking about that you needed to be aware about. And of course, the other phi was always taking 2 pi as the limit starting from 0. Notice that again in the spherical, we don't have anything moving from negative infinity the way Z was moving. So this does not happen in spherical. Does not occur. So now we want to jump to the idea of expressing a vector A in terms of spherical coordinates described by unit vectors AR, A theta, and A phi. And you're saying now that, of course, AR, A theta, and A phi are the unit vectors in r, beta, and phi directions as described in spherical coordinate system. And the magnitude, just like we did with the others, is going to be given by the scalars AR, A theta, and A phi, each of them squared, then you find the square root. The unit vectors A theta, AR, and A phi are mutually orthogonal, something we have been saying over and over again. AR being directed along the radius or in the direction of R, A theta in the direction of theta, and A phi in the direction of phi. And therefore, AR dot AR is equals to 0. AR, sorry, again, I started running myself. AR dot AR is equals to 1. AR dot A theta dot A theta is equals to 1. And A phi dot A phi is equals to 1. But when you cross any two different unit vectors, then you are always going to get a 0. This is something we explained a lot in our second lecture. And so this idea should become quite familiar. And now here's the idea why I was saying over and over again that you need to become very cautious about the position of phi in spherical coordinate system, because you can see AR dot A theta is equals to A phi. If you confused the position of this one, you would actually say that this would become negative. But now, that's how it goes. So A theta dot A phi is equals to AR, and A phi dot AR, cross. Each of this is a cross. A phi cross AR is equals to A theta. Okay, so this we have already explained, and that works well. Now the idea is to express a point that might have been described in Cartesian coordinate system, and now you want to express it in terms of cylindrical coordinate system. And the first one would be the radius. The radius of that point can simply be given by the square of x squared, y squared, z squared, and then find the square root. That works for the radius. And if you want to describe theta, remember how we have got theta here. That might be something new, but we don't need to get scared about that. Can always have it down here. And we are saying that if you wanted to express theta in terms of x and z, what you would do is to find to express these points at that point. First of all, express it at the base. So that gives you this length. This length or this R is the same R here. So I'm getting R. No, R prime. This becomes my R prime. So if I wanted to find R prime, which is the one that is projected at the bottom here, where we have theta is equal to 90, they would simply give me what? We can say that this R is simply the R is equals to x squared plus y squared square root. And then, so now that we know my R here, my R prime, oh, am I drawing it? Yeah, I think it's because sometimes yeah, I want to make sure that the angle that is here is 90. This is my 90 degrees. Therefore, if I wanted now to find this angle, I would simply say, how do I do that? I would simply say that Z or tan of theta is going to be equal to opposite, which is R prime divided by Z, which is the adjacent. And therefore, because we have already found this R prime, therefore we simply say is equals to root of x squared plus y squared divided by Z. So that is, I was trying to show you how you would get theta. Of course, if you want to find theta, you just say theta is equals to tan inverse of this, of x squared plus y squared all over Z. So that is the one I was trying to say that you need to become conversant with. Now, because I can see some people are just a minute. Not there. Just a second. Okay, one last thing. Got that. Okay. So I think I'll deal with that later. I wanted to get the list of the attendees, but I think I can get that later. So I have just shown you how to do this. And what I have not shown you now is how to get phi. Phi is similar. I think we also did this one earlier, because we know phi is a function of the distance, okay, the angle you traverse from x to y. So definitely we did this one in cylindrical. So I don't have to repeat that. Therefore, you need to get conversant with that. And now you're saying that you can also now get, now x, do the reverse of what you have done using from the spherical to Cartesian, meaning Qbot, I cannot answer you because you have raised your hand and you have not even given us your full proper names. So rename yourself, get the proper names, and then you ask your question. I will respond. So I'm saying that there is something that can be done from, let's look at figure 2.5. This is my figure 2.5. And I'm saying, we are saying now that if you wanted to find, how do you want to find? Just a minute. X in terms of r sine theta. So we want to find the dimension of x, which is represented by this point. You see, this point can be described by x, and I think I can just copy this one somewhere so that we get it somewhere we can manipulate with it. Yeah. What is this now? So we are saying that our point is at that point, and you want to find the x that is represented by this r, so which is definitely, how can we express this x? We are first of all going in this direction. This is the x direction. So we want to find out this x that is represented by this point can be expressed how? First and foremost, we need to represent our r in terms of x, and we are saying that we can represent r in terms of x as follows. Okay, I'm hearing that Zoom is consuming more bundles. That is what Murwa is saying. You know what? All you need to do is for me to mute the video, and when I have muted the video, you'll notice that the bundles will become much cheaper. I thought it was easier, good for you to have video, but now that it is consuming more bundles for you, when I mute the video, it will be much cheaper. So your point is taken, Eric. You'll tell me how it goes from now. So, so you're saying that this point can be expressed as x, which is this x here is the x that is represented there. And we are saying that it can simply be given by rho cos phi. Rho is simply the r that I had indicated as r prime, the one that you have not gone up. So that is the first thing. So when you now consider that that x is actually this length when you have not gone up through this vertical motion that is given divided by theta, then you can simply say that you are forming a new triangle that causes the x to reduce by how much? This being, just a minute. I won't find the best way to express this because it might be a bit tricky. That we have we have two wrong issues right there. So this is just like the way we draw the earth with the wrong issues like that. So as you can see, the distance x defined by that point, it diminishes as you go down the longitude. So it becomes maximum at the equator, and then the distance between these two diminish as you go down or as you go up the equator. So it is maximum at that point. So what we are simply saying is that if you have my x is defined as that value at the equator, which is the one that I'm using to represent here, what will it become when you go some how many degrees? Some theta degrees, or theta minus 190 minus theta degrees from the equator. And I think the best way to do that is to do honestly, I can't think. I think my mind is getting tired. I can't think about how can we solve this one. Someone we need to communicate. Tell me how we need to get this one, because it's something very straightforward, except that I cannot see it now. No, I will show you that one later. Because right now I don't know what is your time. My mind is not thinking properly. let's address that one. I will do a small recording to explain how we are going to reduce this distance from how it is currently, from being at the equator to being at this point. That I will do later. So for now, I think I need to finish the class because time is running out even. And we say now that so we are trying to find out how we can express. We have already done this. We have seen how we can express unit vector in terms of the unit vectors of the spherical coordinates. And having done that, therefore, if we have a vector A, we can now replace, just the way we did, we replaced equation 2.2 that was explaining A is equals to AX, AX plus AY, always put the cap and the direction, plus AZ, and therefore, if you just now replace this with the definition that we have just obtained for it here, so it has 3 terms, then what you will actually find out is that this becomes the expression of A in terms of its spherical unit vectors or coordinates. So that becomes is similar to what we did for cylindrical and Cartesian. And I think I have just remembered that we have not derived this one. We just say that similarly the way we did it for cylindrical, you can do that for spherical. But it is important to notice that these are important expressions of how you can convert unit vectors of A or of Cartesian, the unit vectors of spherical, and vice versa. So this is, you can do this transformation from spherical to Cartesian and back. And last but not least, so we have seen that once you have done that, you can actually be able to express, just similar to what we did with cylindrical, you can be able to express AR, or the scalar that represents the AR direction with its equivalent of spherical coordinates, or rather of its Cartesian coordinates. Each of those 3 scalars can be expressed in terms of Cartesian coordinate system. And again, similarly, what we have said you can do in the matrix notation, you can do conversion from the AX or from the Cartesian to spherical. So again, it follows a similar logic. So if you understood the first process, you are going to understand the second process. And I guess that marks the end of our lecture today. Apart from doing the examples, we have not done the examples, and examples are reserved for the tutorial session. So I guess that marks the end of our class today. That small idea that I don't want to spend your time explaining here. I'll just do a small recording and show you how we can, how this length decreases as you go up. Actually, anyway, I don't want to waste your time, but I know we talk about an arc. An arc gets reduced as you move from that. But anyway, I'll show you that in a small recording that I will do at some point later. So that marks the end of today's class. I have received the comment that I should stop sharing my video so that I can save for you some bundles. That is completely understood. Otherwise, that marks the end of today's class. We might meet again on Tuesday. I'm not sure about Tuesday because there's something I have some serious function on Tuesday, but I will communicate to your class or to your class reps about the meeting. And so having said that, unless we have a burning question or a burning comment, I think that marks the end. Before you drop out, let me confirm that I can be able to save the attendees. Anyway, let me get some comments. How the class was. If there are any issues that you had apart from the battles that some of you have mentioned that you experienced. Any other comments? I'm stopping sharing the screen now, and I am also stopping the recording.